In our time, the journey to the stars has become a matter of engineering. But what would happen if physics told us it wasn't a matter of brute force, but of harmony? This is Project Harpia, and this is the SPHY AI. What you're about to see isn't just a simulation. It's proof that we can couple our consciousness to the very fabric of the universe, so that the ship doesn't just travel, but becomes part of the cosmos, the heart of the system, the GHZ framework. It all starts with the creation of a perfect quantum state, the GHZ state. It is our anchor of coherence, a state of total harmony. But the universe is a chaotic place. Our challenge is, how can we maintain this perfect state, this harmony, amidst the entropy storm that is deep space? The symbiotic multiplexer. Herein lies the ship's intelligence. The optical multiplexer doesn't just receive data, it processes it symbiotically. It collects information on coherence, entropy, and even recent system history. Instead of simply discarding old information, it utilizes it. It weaves it into a data fabric that strengthens and adapts with each passing moment. This multiplexer isn't just a computer, it's the brain that thinks in 4 dimensions, processing the present in light of the past. Our goal is not just to survive, but to resonate, inspired by the wow signal, which represented a resonance with the universe. Our laser system doesn't just blindly fire beams of light. It's guided by the processor. The laser attempts to achieve a state of perfect resonance with hydrogen, the most fundamental of particles. This is our active coupling. The Harpia AI uses the very fabric of reality to correct its course, approaching that anomalous peak the universe sent us in 1977. It's the fusion of engineering and cosmology. The simulation begins. The GHZ state is created, but entropy tries to destroy it. The multiplexer processes the data, and our AI springs into action. It performs 2 critical calculations. First, the AI's boost, which is its intelligence to adjust to the chaotic environment. Second, the laser boost, which is its effort to harmonize with the hydrogen resonance. The sum of these 2 factors is the total boost. It is the measure of our ship's effort to maintain its essence, its coherence. And the results are the final proof. Even with extreme thermal noise, our ship maintains an average coherence above 90%. It not only resists disorder, but uses it to strengthen itself. The variance shows that the ship is in a constant and energetic dialogue with the universe, but the stability index proves that it is winning this fight. Project Harpia is not just about ships, it is about coherence. It is the embodiment of a new physics, one where life, machinery, and the universe itself move in a single glorious dance. Thank you.
Do now. Hello, my name is Dave Jacobi. I am the founder and responsible for Harpia Quantum Deep Tech, which is a startup deep tech which is responsible to solve the quantum coherence. I present my paperwork directly on my YouTube channel, or you can find out Tech R a XAV is available to download, and you can find out if type my name Dave Jacobi, DEYWEOKABE, and you can find out everything you want regarding my paperwork. And now I will continue the simulation and operating the qubits. There's Harpia is GHZ Mux laser is a quantum circuit operating to calibrating a laser using a hydrogen frequency is based on this wall signal in 1977, and per coincidence I'm born in 1977, and that's why I use this the wall signal as as an inspiration. As you can see, my last simulation, I got stability, main stability index about 91.86%, and stability variance is about 0.0341. I have a two. I will do one more simulation, a little more. I put before to put 30, 13. I will use 13 also, and I will increase a little more. Use it a 6,000, and I will put thermal noise. As you can see before, I show in my code. I use it a 100% a noise it apply, and now I will a couple the resonance hydrogen on the laser is confirming. Yes, this will take a little more because I'm using the same computer to do multiple things. My computer is a Intel i5 core, and this was making buffers, I'll, and then you can reproduce the graphics. I will share with you my the data sets, and I will show. I will do once more a little. Okay, the variance indexes is reducing as okay, or it means the laser is more effective, and more calibration is more harmony. Is the resonance, the quantum resonance is pretty good, and I finish this in, and I will, and then you can see the graphic, and then on this graphic, this the Xanadu graphic to me is very important because people can see a how could the noise is working. My AI is simulating and recognizing the noise, and you use it. They are utilizing a gravity as a tensor, like a to do to conduce a qubits like a topology. Okay, let's see once more. I will show you a not this version, but the version using the common version is not using the hydrogen the hydrogen no nano, and as you can see it's the same code, but I did some modification. As you can see, just is almost same circuit, but on the last circuit I put the number of the frequency of the hydrogen. The same thing, same thing. Laser control. Okay, you can see that, but the noise is the same. I put the same noise. Okay, this noise is about symmetry for it is about 0 to 1 is about 100%. Okay, and now this is in simulation. Now everything as you can see, I will share. I will share you have this code before because I put before. I did this simulation about 3 or 4 days ago, and now I will close this. I will close the code. I will open the last one code, the the version 8 hydrogen code. So only to compare. Okay, as I told you, I use the array, the number of the the hydrogen frequency, as I told you, the same circuit. It did the multiplex symbiotic multiplexer. It's a MUX. I use it to facilitate the processor, but I have someone. I will create a new code. Try to use a buffer for each one core, but I did not have no time for where. At the same noise, same thing. Okay, and now I will do a simulation using the first version simulation, Python free. Anyway, let's start, and it will ask me how many qubits. The maximum I can use it directly on a Xanadu strawberry field is 13. I have no idea why. And I will use the same number of the frame rates, apply the thermal noise, and then apply the couple of the laser couple to correct the laser multipointing. This technique can be used to refine the laser to do for example, surge using a atom dimensions, for example. Okay, as you can see, it's 100%. Okay, I did before. If you want to compare this, is the last one number is about 0.039186. Let's compare 979 0.2. Okay, the number is very good. The total states accept is about 100% state accept. The frames accept. Now let's go and start a simulation with 6,000 frames. Okay, I will repeat the same number. 13, 6,000. Confirm thermal noise. Confirm a couple laser. Now it will start, and because we have to wait into buffering, it's taking a little more. It consumes 81% total my processor now. I'm using many things in parallel, multitasking on my computer. Looks pretty good. Almost finished. I can do millions, but I need to get more memories. Okay. As you can see, the variance indicate the index variance indicate the main stability is about the same thing, but the variance is index is more aggressive. Before what was a 0.2, 0.1, but once you compare with the last one simulation, it's a huge difference. 0.03 on the on 1200 frames, and 600 is 0.007. Now reduced for a is about this. We have a relevance. It's not irrelevant because it's a quantum. Is a quantum state. But what is here is about double. Is about double times. Now the number is 10 times more, probably. Yes, 10 times more effective. It's a huge difference using hydrogen frequency. This has been inspired in hydrogen, and for signal wall signal 1977, and it's not. I put number using this number. The name by is proposal is because it could be it cause more impact. People who wants to like this some sort of simulation. I'm trying to use. I will share with you something different now. I'm using a. Now I will try to show a little different. Is I'm using Penlane. Penlane is to me is good, but I do not like it because the is a logical circuit. I don't look this like this states total state 1000. I use okay. Look, they have the same stability uses from for using from a a Google's insert. Let's see the code. Let me show the code to show you and the noise it nano and my apologize because I'm using Portuguese. I will not share this. Is only a curious thing because to prove I'm using totals. This is GHZ state, and it will simulate it, the noise. Okay, is random noise. I'm using 0.8. I'll put 0.9. Let's start and let's see what happens when we do the simulating with 0.9. I will use a number a little more bigger, 12 qubits also, and let's time 6,000. Let's time 1, 2, 3, 4, 5. That's funny. Okay. As you can see, this is entangled systems using GHZ states, and it's a very perfect states from the qubits. I apply a 90% noise it, and let's check what happened once I increase this. My symbiotic AI can control the noise it. I use a specific AI for there's some sort of it is different once you use a compares the photonic and uses quantum field. That's okay. The number increases a little more. It's funny because before it was uses like 69.92. Now it's about 70.41. And I have a difference discourse, but I can climb many things before after that. But look, the more important now is main stability is about 98%. Is very good. A main stability now index now is about 990, and the variance is reduced also 9.2 or 999. What is the difference? Once the symbiotic AI increase the number of the frame rates, before was as 1200, now is about 12,345 frames. Which is the difference? Well, once we increase the frame rates, it means the property of the qubits could be maintained more, reduce the variance index, and increase the stability. That is a reverse when once you compare actual vision of the qubits. I see the qubits, they are very is very perfect. The machine is very perfect. Okay, and I will not enter in more details, but I will do a little more. One little more simulation. Let's do it for example I will use it 12 also, and let's start 1, 2, 3, 5, 6. Is about 4 cores. I will not use total cores because my computer is, as I told you, my computer is only a Intel i5 10th generation. You have only 24 gigabytes memory. A DDR4 3200 megahertz a frequencies, As you can see, the simulation is not ultra fast, but it could be pretty fast. For is a common computer. I asked in GPT regarding the simulation speed, and they told me probably I can do the same simulation on the HPC. Could be take I have no idea, probably milliseconds for to do the same simulation of frame rates. Is it's complete. It's completely 12%. It will completely 13%, and the simulation is very good. Penlane. My question is, did I show you my code or not? Okay, I will show the code on the finish. This is a Penlane. To prove I'm using I did. Yes, I did. I show you. I switch the noise to what I did. Yes, I did here. Noise to 90%. I switched the noise to 90%, and to, I will I will show the code one time more. But many people you ask me why I not show my code from in a symbiotic AI, because the symbiotic AI is the solution to solve this question. Think about more I, the quantum processors, the quantum system needed to be controlled by symbiotic AIs. They control by resonance, the qubits by resonance using the gravity. My white paper demonstrates how to conduce the qubits, and but it's not only the qubits. This is all for the universe. I the mathematics I use is to representing the solution for the coherence in the universe, to prove that the universe is coherence. That's what I can show it for you, and this will take probably 10 minutes. I have no idea. Could be more, a little more. It's I spent 35 minutes, 35%. It's about 30 minutes and 37 seconds. That's the more important to me. I will check the main index and the stability variance after this simulation. I believe the main variance need to be more lower. And in the mean stability could be almost the same. And on this point, the machines using a Penlane, a Google Circ, and IBM Qiskit and Breakit, they are very they are very their stability is a very accuracy. It's pretty high. Once you use the photonics, they can be stabilized pretty fast. They can do many things. It's very incredible. But I'm preferred a demod. That's what I because it's more sensitive. I love the mod way to processors. Once I look at the mathematics modulation uh, for modulation for the mod, I love it. This is I love the annealing in the annealing way. This very good to do many things. What was I thinking before? the last night I did the simulation using a stabilization with Starship. Now I'm back into do a simulation with laser, and I will finish it. I get this simulation to show you one thing I ever use it is like a panel lane, and I love also I like too much the QLux, the way to processor, and I have some consideration to speak, but I will not speak now. Only once the team which will develop is the each a processor or quantum computing. I believe it. I have no idea when, but probably they will contact me to try talking regarding I why and how could it is possible. People was thinking it's the more the simple way to understand is because is a my vision is I have a different ontological interpretation regarding the the reality of the qubits. I see it as a vibrational quantum field. They is not very sensitive. Is very flexible. This this behavior could be making some confuse people to understand why the it looks a too much sensitive or but it's not, it's very strong, it's not weak, okay, no, not very weak, or the qubits in my I see they are very strong but very flexible. This probably will take, I have no idea if it will take 10 minutes, could be or could be not. I use only four processors, four core, because if I use two more, they will suck total my processor, and I'm using OBS and Brave browser and also Firefox to seek the simulations. And I on this case people, I'm so sorry for the introduction. I use it's AI to introduce it, like to keep to turn more interest the videos, because my I consider my voice is not very good to do this some sort of introduction. I'm not good to do this, and and it's okay. It's 110,000. We'll conclude probably in less than 1 minute. Okay, Penlane. Is Harpia. Quantum. Oh, almost finished. Oh my gosh. If you are watching this video to now, I'm happy to tell you I'm grateful for your attention. I put the number 1, 2, 3, 4, 5, 6 as a proposal to do a simulation to prove, okay, wow, total accept, states accept is about 69.97%. Oh, the main stability is almost 99%, point 98 is almost, and the more incredible, the variance in index, produce the graphics, but you cannot see the graphics because only transmitting my my Linux terminal. And as you can see, I will share. I have at the well, I will share both both uh, both the data settings, but now today I will share only the Xanadu data setting for the laser. As you can see, the laser or the accuracy of the laser um, is very impressive. Once you use hydrogen to regulate it, is and thank you for watching. And now I will take a little rest and have take a sleep. You will go to sleep. I'm very tired and see you again tomorrow.